All right, what we're looking at here are whether we have differentiability and continuity at a point given a piecewise function. And this is a very common AP question. So, does the limit of f of s exist as x approaches 3? To figure that out, I just need to plug in 3 into my two equations here. So when I plug in 3, I would get 5 from this part of the piecewise. When I plug it in here, I get 12 minus 7, which is also 5. So that means, yes, from both directions, the limit is the exact same thing. So yes, the limit does exist, and the limit is equal to 5. Is it continuous? Well, the limit is 5 from both directions, but we need to check, well, at x equals 3, what is the function? Well, right here, it is 5. So yes, it is continuous as well. We have both the bridge, and we're approaching the bridge from both sides. And the last part, is it differentiable? Now to do this, we need to actually take a derivative. We need to do both parts of the piecewise function. So when I take the derivative of the top, it's just x, or I'm sorry, it's just 1 because it was just x. And the derivative of the bottom is 4 because I had 4x. So when I look at 3, if I plug in 3, well, there's nothing to plug into. So my derivative here is 1 from the left and 4 from the right. Are those derivatives the same? No, they are not. Therefore, it cannot be differentiable at that point because 4 is not the same as 1. All right, here's another example. I'm even going to say pause the video and see if you can come up with the answers, even though I kind of already gave you one. All right, so let's see what you found. Does the limit exist? Well, I need to check then from the left. When I plug in 1, I get 1 plus 2, which is 3. When I plug in from the right, I get 4 minus 1, which is also 3. So yes, the limit does exist, and the limit is equal to, as you saw, 3. Now, is it continuous? Well, this is what's happening. You're approaching the same spot, but we need to know if that bridge is there. Well, the bridge is right here, but the answer there is 2. So really, it's like we have an open circle and then a dot below it. So no, this is not continuous. Now, to be differentiable at x equals 1. Well, we've talked before how if a function is differentiable, that means it must be continuous. Well, that means that if it's not continuous to begin with, then there's no way it could possibly be differentiable. So our answer here automatically is no because it is not continuous. Now, the other way you could even look at this is if you did the piecewise for this, you would do each step along the way. You have f prime of x would equal, we have 2x plus 2, 0, and then just 4. Well, when I plug in 1 here, this becomes 4. This still becomes 4, but really I have this discontinuity where I had a derivative of 0 in the middle. Those are not all the same. So it looks like a smooth curve. If there wasn't a hole there, it would be differentiable. But because of that hole, we cannot say that we can take a derivative at that point. You can't take a derivative if there is a discontinuity there. All right? So there you have it. And again, you're guaranteed to see one of these questions.